Hello everyone, my name is Ander Zubiria. I am researcher at Power Systems in Technalia Research and Innovation, and today I will teach you the third lesson on second life battery management, maintenance and safety as part of the course 5 on second life batteries of the CISA project. In lesson 3 you will get useful information for second life battery management, maintenance and safety. So first, key technical specification of second life batteries will be shown. Then we will show the main monitoring, control and communication architectures of second life batteries. Afterwards, some key aspects on second life battery safety will be exposed, and finally some guidance on second life battery maintenance and usability will be provided. So in this table you can see an example of a second life battery dataset where key technical specifications are provided. So these technical specs serve as a guideline for suitable second life battery selection. In this regard, it is especially relevant the information related to maintenance and safety from the point of view of environmental aspects like ambient temperature or humidity, but also the implemented fire detection systems, thermal management systems, and all the electrical protection devices. Additionally, on second life batteries, it is especially relevant to consult the warranties provided by the manufacturer and also the standards that are being complied by this to ensure that the product is of high quality. Batteries are made of many components that interact among them, so it is important to know how these elements interact and also how to monitor them to better manage the battery system. Lithium-ion batteries are monitored at different levels with the overall goal always of maintaining safety and system efficiency. On the very lowest level, the device in charge of monitoring and controlling the system would be the BMS or battery management system, which is divided into three different levels. First, we have the battery cell level, where voltage and temperature are measured with very high resolution and very high sampling time. In any case, not always single cell voltage and temperature measurement is available for the battery. Then we have the module level, which is a higher level compared to cell level, and in this case, voltage, current, minimum and maximum cell voltages, and also module temperature are measured in order to estimate the state of charge and also the state of health of the battery. Lastly, we have the battery pack level, which is the higher level of the BMS, where voltage and current are measured. As we can see in the figure 1, we see that the BMS interacts with higher level monitoring and control systems like the energy management system or EMS, the thermal management system or TMS, and the power electronics that are connected to this battery, and also the fire suppression system in charge of avoiding hazardous situations like fire. So internally, all these data are communicated using different protocols like Modbus TCP, CAN, or RS485. Moreover, external communication with the electronic device or the PCS, the grid, or other elements external are carried out using also protocols like Modbus TCP, MQTT, or the IEC 61850. Communication alternatives between these elements could be shared lines like the existing power lines or telephone lines, creating specific lines to communicate these systems, but also using wireless communications like Wi-Fi, Zigbee, or Bluetooth. Second life battery safety can be divided into two main types. First, thermal safety, and afterwards, electrical safety. Thermal safety is made of two main system layers. The first layer is a preventive system built of the BMS and TMS interaction, and it is based basically on the constant status monitoring by the battery management system and the communication with the thermal management system. The thermal management system goal is to dissipate the heat from the battery using different type of fluids and a set of logics that are used to adapt these set point temperatures and the flow rates of the cooling fluid. Nowadays, there are two main categories of thermal management systems. Air cooling systems, mainly based on HVACs and fans, and also the liquid cooling systems made of hydraulic systems with pumps, channels, and heat exchangers. The second thermal management system is a corrective system, so the system would be already acting on the system based on the fire suppression system, different sensors to detect heat or fog, and some alarm devices to advert of this fire event. These sensors are also connected to the battery management system. The fire suppression system are based on different fluids like water or other chemicals. Electrical safety of batteries is based on the coordination of the battery management system and all the electrical protection devices that are installed in the battery. So the main duty of this system is to prevent from different electrical hazardous events like overcurrents, overcharge or overdischarge, or even reverse polarity events. For that, different electrical protection devices like fuses, disconnection switches, and isolation meters are installed in the battery. So as you can see in figure 3, all these electrical protection devices are usually centralized into a same box or a same system element that is named battery protection unit. So battery maintenance is key to preserve the minimal loss of energy yield of the battery while avoiding damage or repairs for this battery. So three main types of maintenance stand out nowadays. First, we have the corrective maintenance, which is basically consisting of repairing periodically the battery elements when a consistent damage has been caused. Then we have the preventive maintenance based on diagnosing the state of the battery and acting, but only when a non-critical burden has been crossed on the system. And lastly, we have the most advanced maintenance type, which would be the predictive maintenance, based on predicting failure before any damage has been can happen to the battery by using historical data of the battery management system and aging models and prognosis algorithms. This is a piece of advice on second life battery maintenance and usability. So it is very important to maintain module accessibility in case of single element damage of the battery. Additionally, advanced monitoring system implementation is key to avoid premature damage of battery systems. As to environmental aspects, it is very important to adapt the place where the battery will be installed to the datasheet environmental characteristics provided by the manufacturer. Additionally, it is important to avoid situations of excessive shock and vibration for the battery, and also limiting the accessibility of third parties to this system. For usability, it is especially interesting the modularity by design concept in case we want to increase or upgrade the battery system or add a new element to it. Additionally, avoiding overheating situations, but also deep and fast cycling situations are very interesting in order to extend battery lifetime. For non-technical users, easy installation is a key feature. And lastly, incorporating inverter solutions will help in terms of compatibility with electrical and communications coupling. For more useful information on these topics, here you are some additional references. So this is the end of lesson 3 on Second Life Battery course. Thank you very much for attending. See you in the next lesson. Bye.